Until here, our data preparation, we are
Sorry,
doing
sir.
our data preparation. Yes,
Sorry,
please.
sir.
Yes, yes.
Sir, kindly explain the concept of communalities, sir. This is
Yes.
confusing, sir. Communalities. Please explain the concept of the communalities, sir.
Okay, okay. Okay. Brother Shahriar, can you explain, brother? Brother Shahriar, are you there? Or anybody else can explain the communality, the value of communality?
It is a variance
Yes.
accounted for a particular variable by all other factors. So it is a
Okay.
variance accounted for particular variable by all other factors.
Yes, very nice. Your name, brother?
My name is India, Kerala.
Oh, okay. Cynthia, huh?
India.
No, no, no. Your name, your name.
Sujit.
Sujit, brother Sujit. Thank you very much. Actually, the concept of communalities
Yes, sir. Yes.
is the sharing with other items, or you can say the concept, the nature of the questions or statements, how it is related with the other one. Okay.
Okay, sir.
Okay, so how it is correlating with each other, the same like actually the question similarities, meaning the communalities. Okay, anybody have any good answer, more good answer in a statistical point of view?
Like, sir, in this case, initial extraction 0.708 means what, sir? Wage 1.
Okay.
0.709 is the value, so it means what, sir?
It is so far my understanding is concerned with uh, 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 mm, mm, okay.
Sir,
So yes,
can we say
yes, yes,
in
yes, yes,
shorter, in
yes, yes,
easier
please.
way, like where EFA is the relation between the variable and factors.
Yeah.
The communal that factor is maybe the relations among or between the variables.
Um,
Like EFA can be explained like a relation between factor and variables. So commonalities can be explained something like a relation among the variables.
mm, I think it is the loading actually, with its own with its own variable, that is here it is showing. However, I don't have, I never think of like this. So anybody from you who has a good answer?
Sir, actually,
I hope. Hello, sir.
Yes, Professor Mansoor, please.
I do think if community is, shows that if the value is nearing 1, this shows that the means the loading of the item is going to even make even a rather good construct. Means it gives you rather just a hint. Okay, but from the table of RCM we better understand uh, the items which are going to converge into a respective factor.
Yeah. Yes, exactly. Here it is. Okay.
From the RCM table, rotated component
Yes,
matrix,
rotated component matrix.
we
Yes.
can better understand if all the items are loaded into their respective factor.
Yes.
That means conversion validity is established.
Yes. Here it is showing the conversion validity. Actually, all items
Okay.
are loading with its
Yeah.
own variable. So it is
Yeah,
converging towards its own variable. It is showing.
exactly.
But
And
the communality
if
values, what does it
if they
mean actually?
are
Yeah.
if the items in RCM table or rotated component matrix table, if all the items are highly loaded into the respective factor, means constructibility has been established. And thirdly, if all the items are loaded into the respective factor as compared to the rest of the factors, this means this established that a discriminant validity has been established. In my even limited information, I do think.
Yes, Prof. I have the same one, but
Okay,
I
thank
think
you.
for in the case of the communalities, I was expecting more accurate answer from anyone who
Can I
has.
say something, sir?
Yes, yes, please.
Okay.
Okay. We can refer to it as the quota contribution of each item to a latent variable or particular factors. I was talking about variance that can be explained in a particular factors. That is, when you have a unidimensional, just like as you showed to us. So those items, they have different contribution to that particular the factor they intend to measure. So we can call it their quota contribution or the variance that can be explained in that factor in which they measure.
Yes, brother.
Am I on the track, sir?
Yes, hopefully. Yes, it is. So far, I understanding that this OS one, it is contributing 70% to its own variable, and OS 2 is 72% with its own variable, like this. It is commune with its own variable. This is the result. Okay. So, however,
Okay, thank you, sir.
okay, okay,
Hello, sir.
yes,
Actually, I get the different results.
okay,
I cannot understand why. Am I correct? My method is correct or not? I have sent you the photo to your WhatsApp.
okay.
Actually, sir, may I share my
Yes, yes,
screen?
yes, yes, brother.
Uh, uh, uh,
Shantosh.
1 minute.
Yes, yes, please share your screen, brother. No, rotated component. Okay, brother, go to analyze. Brother,
Uh,
go to
yes.
analyze. Go to analyze. Maybe you cannot select the.
Go to analyze.
Doctor, Assalamualaikum, Doctor.
Yeah.
I think he choose the covariance instead of correlation.
Yes. Okay. Okay. Click on there. Okay. Go to descriptive.
Descriptive.
Okay. 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 Continue. Continue.
Continue.
Extraction. Okay. I think it is sister. It would be Johanna. I think it would be correlation
Correlation
matrix.
should,
Yes. Yes.
should be correlation.
The correlation matrix. The first one you have to select.
Okay, sir. Okay.
Okay. Okay.
Okay.
Okay. Then continue. Okay. Stop sharing, inshallah.
Okay. Thank you, sir.
Okay. So, testing.
Sir, I have a request, sir.
Yes.
Can you share the details? I mean, how to interpret the result of factor
EFA.
analysis?
Yes, yes. I shall
EFA.
do. Yes, I shall do it.
Okay, 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 sir. Thank you, sir.
Welcome. So, testing of means. This is very important. T-test, then ANOVA test. When some yes.
Sir, I understood how to do EFA, but I didn't understand the things like the rotated component matrix, KMO, and also. Can you please explain once again, sir?
Actually, I cannot explain in a very very in-depth one because my background not the statistics. However, what I understand that in KMO it has some requirement, and these are the different requirement that we need in our data set. We have this requirement, fulfilling this requirement or not. These are the basic things that I know, but for very in depth, what is Verimax, what is different other rotation matrix, and it is very difficult. Even I have to spend many years for learn everything, but it is not my area. That's why I did not concentrate more on this. So just I know the basics and what is our requirements. Those who are specialized in statistics, they can explain more better way.
Sir.
This is my limitations actually.
Okay.
Yes, please.
Sir, I believe that KMO shows the sample adequacy, whether the collected sample size is enough to even run EFA on the collected data set.
Okay.
Okay.
Yes.
And Bartlett Test shows that all the items are even whether highly correlated with each other or not.
Okay.
Means it is going to be determined on the sig value.
Okay.
Means R, the hypothesis R is all the items are not even correlated with each other. Null hypothesis of Bartlett test means all the items are not highly correlated. If it is supposed to be rejected, this means all the items, all the indicators of the data set are highly correlated with each other with respect to the factor. So, in my even limited information, this is only the value from the sample size, which is 0.888, means the sample size is adequate enough to run EFA.
Yes.
Bartlett test of shows that all the even items are correlated with each other.
Okay.
This is what I know from the this table particularly.
Okay.
Sorry, please can we move forward?
Yes, yes, please. Okay. So testing of means, this analysis illustrates that whether there is difference between two groups or among three groups and it is significant. Here two assumptions. One is if data does not come from normally distribution or sample size is small, meaning that less than 30, then non-parametric test you have to select. If data comes from large and normal distribution, then parametric test. So for the case of non-parametric test, we have these are the assumptions: sample size less than 30, do not perform normally distributing. When data is not normal anyway, regular statistics cannot be done. In non-parametric test, we have Kruskal-Wallis ANOVA and Mean-Whitney U test in the case of 2 variables, and more than 2 variables you have to do the k independent test. And in the case of the data are categorical, in that case non-parametric chi-square test you have to perform. All these tests are non-parametric tests, but today we will learn only the parametric test, that is if your data is normally distributed. And here in the parametric test we have 1 sample t test, 2 sample t test. Within the 2 sample t test we have independent sample t test and pair sample t test, and if more than 2 sample, then we have to do the analysis of ANOVA. So what is 1 sample t test? The 1 sample t test compares a sample mean to a hypothesized population mean to determine whether the 2 means are significantly different. The 1 sample t test determines whether the sample mean is statistically different from a known or hypothesized population mean. The 1 sample t test is a parametric test. This test is also known as single sample t test. The variable used in this test is known as test variable. In a one sample t test, the test variable is compared against a test value which is known as a hypothesized value of the mean in the population. However, in 1 sample t test, the 1 sample t test determines whether the sample mean is statistically different from from a one or hypothesized population mean. The sample data must comply 3 conditions: scale data, normally distributed data, only 1 sample data. Suppose example of 1 sample t test here. Okay, null hypothesis: the 1 sample the sample mean is not significantly different from the hypothesized population mean. In alternative hypothesis is the sample mean is significantly different from the hypothesized mean. If the p or significant value less than 0.05, then we reject the null hypothesis. So what is 1 sample t test? Here your sample sample is one set of sample. Here what the results given, the sample given, you assume that based on your assumption you will assume that this can be the mean value. So based on your assumption and what is the actual is coming, so the difference between your assumption and your assumption means your hypothesized value that you are determining. So what is the difference between this actual mean and your hypothesized value? If this difference is really significant or not. The null hypothesis is telling you that there is no significant difference between the actual mean and the hypothesized mean. But in the alternative hypothesis, it is telling there is a significant difference in the between the actual mean and the hypothesized mean. So if we find the p value is less than 0.05 or the t value is more than or equal to 1.96, then we reject the null hypothesis. Then we accept the alternative hypothesis, that is that there is a significant difference between the hypothesized mean and the actual mean. You got the point? Is it okay? Now we shall do it practically. Practically it is easy, very easy. When we will do during our practice, when I will explain, then it will be very easy for you. Okay.
Yes, sir. Yes, sir.
Everybody please go to the data file and open the file one sample t-test data set. Open this file. If we check the data here, GPA of 15 students, it is given. Here you see. Okay, explanation. Okay, direct. Okay, no problem. Okay, 15 students GPA score has been given. So now we are assuming that the mean score, the mean GPA is 3, but we don't know what is the actual. Now our assumption is 3. Now we shall calculate the actual one. Now what is the difference between this actual and the 3, the hypothesized mean that we have determined, that we have considered the mean value might be 3. So what is the difference? So everybody please go to analyze and go to compare means and one sample t-test. Just select. Yes, please.
Yeah, before you go ahead, can I ask you a question? Yeah.
Please.
Hello, sir. You told that hypothesis would be mean is 3, but it's a numerical, right? Can we make any hypothesis statement, like if I want to make any hypothesis based on statement, that hypothesis can be explained, rejected, or accepted through using SPSS? Is it possible?
Yes, our hypothesis here that there is a significant difference between the actual mean and the hypothesized mean. Here is alternate. Our hypothesis is for testing this hypothesis. We are doing this test. Okay, please follow me.
Okay.
Okay. Please go to compare means and one sample t-test. Select one sample t-test. Okay, just select this grade point average GPA to the right side and options. Go to options. Confidence interval 95%. Why this confidence interval 95%? Anybody have? I think many people can explain this very nicely. Yeah.
The degree of confidence we have in the data, that is almost 99 point, we have 95%
confidence
assurance that yes,
assurance of
confidence in
our
the data
study.
is correct.
Actually, sir, it gives the degree of assurance that if that range of values that you can be 95% certain about the degree of assurance that contains the population means. It's mean if we can repeat 95% this study, so our findings will be 95% of the time within this particular range.
Yes. Actually, you know, in social science, we consider if our study is 95% accurate, then we consider our study is valid. Okay, in the case of social science research, but in the case of medical science, because in that case it should be at least 99%, because they deal with the human body, human life. So that's why for our social science our precision level should be at least 95%. Okay, so then continue. Then our test values is how much? We are considering our GPA is 3, right?
3.
Yes.
Yes.
Okay, 3. Then let's see the result. Then okay. Okay. So grade point average, the number of samples is 15. Our mean score is 3.7. Okay. So what is the difference? We will consider 3 in between
0.7.
yeah, 3.7 minus 3, right? Or 3 minus 3.76. So 0.76 is the difference, right? Here.
Yes.
So here, see, the either this 0.76 is really significant or not. This is giving the probability report. It is showing that it is 0.000, which is less than 1.96. Sorry, 0.05.
0.05.
Yes. And another is 95% confidence interval of the difference. Here lower bound and upper bound also giving. Here if both are positive, lower bound and upper bound both are positive, and or both are negative, that means the 0 not in between or 0 not in straddle. It is meaning that there is a significant effect or significant relationship, or significant it shows that it is significant if the lower bound is negative and upper bound is positive, meaning that 0 is in between, meaning no significance. The probability would be more than 0.05. So that's why it also we will observe any either our assumption is significant or not, our hypothesis is significant or not, by two things. One is we will observe the p value and lower bound and upper bound. Okay, so here it is the significant is less than 0.05, means it is significant, and it is also confirming from the 95% confidence interval of the difference. Lower bound is, and upper bound both are positive. That's why we can say that we can come to the conclusion that there is a, since the value p value or the significant value is less than 0.05, meaning we get the 95% confidence in our study that there is a significant differences between the actual mean and the hypothesized mean. Okay,
or we can say, sir, that sample means is significantly different from the hypothesized population mean.
Yeah.
Here the population mean is cutoff value of 3. So we can conclude that sample mean is significantly different from the hypothesized population.
Yes. Since the significant value less than 0.05, which means we reject the null hypothesis, it indicates that the sample mean is significantly different from the hypothesized population mean. Thank you very much, brother. Yeah.
Sir, this is with regard to data when it is normal, we are going for parametric test. If the data is not normal, then how can we know that the population mean and the sample mean is same or different? Whether this sample is being derived from population or not, how can we know?
Yes, brother Shahriar.
Then we will go for the non-parametric test, which sir discussed a little bit earlier, that if our data is not normally distributed, then we don't go for the one sample independent test, we go for the Mann-Whitney or other type of statistical test.
Yes. Mann-Whitney U test, or yes, or guys, yes. I think for one sample t test, I think
If sir, I will explain it. If data are continuous, then we first analyze that either data is normally distributed or not normally distributed. If data shows a normal bell-shaped curve for that particular variable, then we go for the one sample t-test. If data is not normally distributed, then we go for the Mann-Whitney U-test. In second case, if the data are categorical and not normally distributed, and we found the association between the two categorical variables, then we go for the chi-square test. Otherwise, in case of parametric data, we can go for the regression. Thank you.
Okay, sir.
Okay, brother. I think it is okay, inshallah. Quite.
Yes, sir. Okay, sir. Thank you.
Okay. So,
Sir,
yes.
sir. Sir, actually, Wilcoxon signed rank test for not normally distributed data. Man-Whitney for two independent population. I think so. Two independent population mean.
I think for one sample t-test, in the case of one sample t-test, you can. It is not required to go for either it is parametric or non-parametric. You should do the one sample t-test. Okay. If you have two variables and it is not non-parametric, if it is not parametric, then you have to go for
Man-Whitney.
Yes.
Yes, sir.
Mann-Whitney. Okay. What is independent sample t-test? The independent samples t-test compares the means of two independent groups in order to determine whether there is statistical evidence that the associated population means are significantly different. The independent samples t-test is a parametric test. Okay, suppose we have the sample of male and female. Here their male student and female students GPA score been collected. Now null hypothesis is telling that there is no significant difference between male and female towards GPA score. In alternative hypothesis is telling that there is a difference between male and female towards GPA score. So let's check either alternative hypothesis is established or null hypothesis is established. So go to analyze, compare means and independent in a sample t-test, and we will do the analysis. Okay, and all are very easy, alhamdulillah. So 11 number, please open 11 number, independent sample t-test data. Okay, here everybody open it, independent sample t-test data. Open it, go to analyze, go to compare means, independent samples t-test. Select the independent samples t-test. Here the test variable is GPA score and grouping variable is our gender, right? Gender. So gender, you have to define the gender. Gender 1 is male, 2 is female. Okay, then continue, and option 95%, it's okay, it is by default given, then okay. Male and female.
Please repeat, sir, how to write the gender grouping variable.
Okay. Did you open the file, this one, independent sample t-test? This one, 11 number file.